Hello. Another follower. Ooh, another one. I've somehow lost all my better TTV emotes. Harumph. How are we all doing today? Bizarre mix we got going on here. Let's try this one. Can you hear the audio coming through, hopefully? It always works fine when I test things out, and then when I go to actually go live, it stops working. Awesome. It's almost go time. Cool. Got a YouTube video or two to play during class, so I want to make sure you can hear it. Much appreciated. We will see how this goes. I'm still up in the air if we do Twitch or like Zoom for this class, just because of how much coding I want you all to be doing in class. We'll see. See how it goes. Okay, cool. Yeah, if you're fine with using your, your normal Twitch name, that's alright for me. Fun part's gonna be when we go back to reality, and I'm not gonna know anybody outside of their, Twitch names. Aquatic Pickler, and MLG Angry Carrot. Those are some great names this semester. I love it. Hey, it's 4 o'clock. That means. Fair enough. All right. Now, I should make this slightly bigger. Let's go 28. Yeah, that's handy. Is that better? That's better. Hey, oh, you friends. The best part is when people pick names that sound like real world names in Discord, and their name is actually nothing like that. It's hilarious. Alrighty. Let's get going here. So, fun times abound. Alright. So, welcome to computer graphics. So, my name is Eric Frederick. So, this class is kind of in an odd time slot. I assume for most of you, 4 to 5:15 is hopefully we have some energy left over from everything else during the day, but we'll make it work. It should be fun. Graphics are a ton of fun. I think they're kind of a fun little excuse to, play around with visualizers, make video games, cool things like that. At least that's how I like to view it anyway. Um, what we're going to be doing in this class is we're going to start out with WebGL, and we're going to kind of transition over to Blender and Unity towards the end. I'm kind of giving you the high-level stuff early on, just for funsies, I suppose. There is no textbook for the class, so it should be hopefully a nice thing for all of you. Now, I've got one here at the bottom, so it's kind of the footer there because I based a lot of the material off of it. It is a very well-known graphics book, and I've got to imagine the library has it because this class has used it in the past. I'd have to check that, I suppose. But it's a really nice intro to WebGL. So let's talk about graphics in a little bit more detail. So this is the book I was showing you. I think there is an 8th edition out there. I like the 7th. I haven't checked out the 8th one. But again, it's not required, so you don't have to worry about it. If you want to pick it up, it's a nice little reference to have on your shelf. I've got one, I think, somewhere. I've got several graphics textbooks hiding. I might have left this one in my office at Grand Valley. Yep, I don't have it on hand. But I've got the book website here too. So they've got a bunch of information up there if you want to check it out. Like here's the Git repo, PowerPoint lectures, videos from the, what's the World Edition? Oh, never mind. But a lot of code out there, and I've actually forked their GitHub repo and fixed it a little bit. So that will be there for you. We'll talk about that. But the one thing I will say, if you do want to, oh, you know what? I've got a, sorry, let me, oh crap. I've got to turn auto hotkey on. Otherwise, it's not going to work. And it's not going to work anyway because it's just not here. Sorry, fiddling with my computer here. Crap. Oh, we'll just do the Google thing. I've got a nice little highlighter on my cursor now, and then I killed my auto hotkey script apparently. The only thing about the textbook is that if you find this book and you want to use it, everything before the 7th edition is OpenGL. 7th edition and after is WebGL, which they're two very different things. So just be aware of that if you're searching out the textbook. Again, not required, so it's not a huge deal, but more so if you want a reference for that. So I've got, let's see, 20 people in this stream, so I'm going to assume 15 of you are bots, and then the rest of you are students. So that's good, you found the lecture okay. And I'm going to assume everybody saw everything on Blackboard, my little intro spiel. So a couple things that I want to highlight before we really get into things too much. If you ever have any questions, any problems, any concerns, you don't know how to do anything, you need help, ping me on Discord, message me on Discord, drop me an email. come to the office hours. So they are Monday, Wednesday, Friday, 10 to 11. I've got a Blackboard Collaborate link for you in multiple places in the Blackboard page. Make use of that. And if that doesn't work for you, just drop me an email and say, hey, can we meet at such and such a time? Usually I'm more than happy to, set something up with you. So any issues, please come to me before it becomes a big problem. Um, Usually, if you let me know in advance that something's going on, we can come to an agreement or come to a solution for it. This applies to things like homeworks, projects, things of that nature, or really anything else. So just want to kind of get that out there. My goal is to be very, very approachable for all of you. I know we're kind of still in a weird situation with doing online class, but we'll try to make it work. Okay, it went pretty well last semester and the semester before. The students who talked to me in advance or let me know what was going on were successful. The ones that didn't talk to me and just kind of, didn't make use of that, they had a harder time. So just kind of be aware that's my little spiel for you there. So the syllabus. I do not have a syllabus exam for all of you. Unfortunately, I can hear the virtual tears that you're not getting a syllabus exam like you get in some other classes. But it's kind of intended to be more or less our contract for each other. So it's got the description for what we're doing in class. Let me make it a little bit bigger here. So there is your boilerplate stuff out of the course description. Here's my contact info. Again, Monday, Wednesday, Friday, 10 to 11 on Collaborate. Feel free to check that out. Discord, I'm going to guess you've all visited. If you haven't, I would highly recommend doing so. Let me bring this over here for a moment. So basically, we're going to do in-class discussions on here at times. So there's 367 specific stuff. Pop your memes in there, pop whatever you want to do in there. Just, more or less keep it family friendly because it's not an official thing, but it's a good place for all of us to be together. And again, I have it on my phone. I've got it on my computer. Feel free to drop me a message if you ever have any questions or anything like that. We'll have a midterm and a final halfway through, and then towards the end, my guess is that the midterm's going to be mostly WebGL. Final's probably going to be mostly Unity and Blender. When we get closer to the end of class, it'll probably be a little bit more project heavy too, would be my guess as to how it goes. Just some things to be aware of for that. So the only other real things to talk about in here, recording. So I am recording these for your benefit, and I forgot to hit record, so I'll just pull it off of Twitch afterwards. I will put them all up on YouTube after class, and they will be accessible in the place where you find the PowerPoints in Blackboard. So just what I'm going to be doing is, come on. Where is this? Come on, come back, please. Google Slides has been acting very bizarrely for me lately. All right, while I pull this up, how are you all doing today? Apparently I got logged out. All right, so we were talking about recordings. So the only reason I'm talking about this is that last semester I got some comments saying people had no idea where the recordings were in class. If you go to the slides, I'll put the recording link right in here. So like the lecture from today, I'll have a link for the VOD, the video on demand. It'll just be right there. So all the videos will be linked in here. And while we're in here, assignments, these will all be here. You're going to have an in-class assignment coming up. You've got a lab that's coming up, and those will all pop up in here for you when I make them available. They're not available yet because, hey, we haven't talked about stuff for that, and it kind of would make sense for that. Other stuff. So, two other things. I've never used Twitch. Do I need to log in? No, you do not need a login. You need a login to talk. So if you want to drop messages in there, like you just did, you need that to chat. You don't need one to just watch it though, if you want to passively listen. So yeah, no problem. And like I said at the beginning, I don't know if anybody missed this. This class is going to be a little bit more programming heavy, so I'm on the fence if we're going to stick with Twitch. It's what I've been using for all my other classes. This is probably one of the more programming heavy classes I've done recently, so we may shift to Zoom or Blackboard. You will all get a million emails from me if that's the case, just to remind you. But for now, we'll stick with this. So two other things for the syllabus, and then we'll be done with this. I'll let you read it on your own terms. Um, I would recommend reading it though. There are two things. So the points for the class. This is a slightly different way for handling class. If you've had Professor Moore, you've probably seen this. Everything is a flat amount of points for the class. So if you um, look at this, basically the midterm, the final, 100 points each. Term projects 200. Coursework, which means your homework assignments, 500 points. Participation, which is going to be, I have a million pop-ups over here for that. Like in-class assignments, you'll get little notifications and Blackboard links for that. Since we don't have in-class stuff, I'm not going to be able to say, hey, get in a group, write down stuff on a piece of paper and turn it in by the end of the day. Participation will be just little Blackboard assignments that are like 10, 20 points a piece, something like that. And for those, if you happen to miss the class, I usually make them due by midnight, either the same day or the next day, depending on how difficult it is. But the nice thing about doing it this way is that every point evaluates to the same thing. So 10 points in participation is the same as 10 points in coursework. So take from that what you will. Basically, you can just take the number of points you've gotten, divide it by 1,000, see where you're at, kind of a thing. So should work out okay, I think. And again, if anybody's struggling or has any questions, please feel free to let me know. Okay, so last thing I promised on here. So cooperation and cheating, this is something I have to always stress that I take a very dim view of cheating, mainly on things like exams or assignments that you're supposed to work on by yourself. If you cheat and copy and paste stuff from other people or from the internet just verbatim, I'm probably going to recognize that. If you sneak it by me, that's, fine for you, but basically the point is to try and actually do the work. If you're struggling with the concept, just let me know. It's easier to get it right than to cheat, I think. Only reason I say this is one semester I had half the class cheat on an online exam and it made everybody's life a living hell. So just stress that. Don't cheat. It's going to be better for all of us if you don't. And if you do, it's very painful for everybody. If you have any questions about what constitutes cheating, please let me know. Basically, I'm just looking at things like don't copy and paste answers from other people. If it's an assignment where I'm asking your opinion, don't copy and paste something off Wikipedia. Distill it and cite your source, kind of like you're expected to. But just don't do it if you can avoid it. And again, as the professor who can see all of your answers, it tends to become obvious, especially when formatting tends to persist when you copy and paste things. So yeah, that's pretty much it for the syllabus. I don't have exact dates on here for the exact modules just because it just depends on how long it takes for some of these various things. I'm going to guess the first couple of days are going to be the intro slides here. What we're going to do on Thursday, you'll get an announcement from me pretty soon. It's going to actually be over Zoom, so it'll be different. But we're going to do an in-class lab on Thursday. And the point of that will be to kind of walk you through the setup and how to get your programming environment going, try some things out and things of that nature. So, but look for an email from me on that one. Okay, questions on the syllabus or general like course concerns or questions or anything like that. Should be pretty straightforward, I hope. But again, if you're concerned or you don't know, maybe you have a question, feel free to ask that in the chat there. Only other thing that I'll mention while I'm waiting to see if anybody has any questions. So for this class, at least the way I have it structured, the easiest way to ask questions is going to be through the chat in Twitch. I also have some slides where basically you'll see one in a couple here where you can like give feedback and interact, and I can answer questions and things like that. But yeah, easiest way would be through Twitch for that. But if we're all good, we will move on. All right. So expectations for the class. Now, I'm going to guess at this point that not everybody has learned JavaScript. That's probably a good assumption, right? You've done Java by this point, um, if I read the prereqs correctly. But you can pick it up pretty quickly if you know a common programming language. If you're not aware, Java and JavaScript are not the same thing. They're very, very different. JavaScript has basically become the de facto language of the web. And since we're doing WebGL, it's all based around JavaScript. So if you already know that, great. If you hate JavaScript, even better. You know what's wrong with it. If you have no idea what JavaScript is, we will pick it up along the way. I'm not really expecting you to be a JavaScript expert. I'm expecting you to be able to pick it up as we go. Other things which have been concerns from people in graphics in the past are the amount of math that is involved. I am the type of person who is not good at matrix math. I am fully able to admit that. And the great thing about WebGL and most graphics programming libraries are there exist libraries and modules to handle all of that painful math for us. So we're going to kind of abstract that out. Now, do you have to know some linear algebra? Yeah, we'll do a little bit of that. Now you have to do some basic things, but kind of the key thing here is to know when to apply the correct libraries. And as somebody who is not good with matrix math, again, I can assure you that you can do this, and it's going to be pretty neat what you come up with in the end. So just kind of be aware, those are the expectations. A little bit of math, some JavaScript. Later in the semester when we touch Unity, that's all in C#, which is very, very Java-esque. It's not too much of a stretch if you've, know how to program at this point, but be able to pick it up. I'll walk you through it. If you're struggling, again, let me know and I can help you out there. Actually, this is not valid anymore because this class is no longer special topics for me at Oakland. It is a official class here at Grand Valley. There is a prerequisite for this class, and it's the number again. Prereq is, if you've managed to get in here without it, you need 263 and to be a CIS major. So we've got that going for us. So yeah, be comfortable with coding, be able to pick up a new language, be decent with math. One other thing too, which is going to be helpful, is to be able to navigate a Linux terminal. This is mainly going to be for uploading your websites that you're going to be doing. So in this class, you're doing WebGL, which means it's going to be browser-based, which means you're going to have to move files around on a file system. Has anybody here, I guess let me ask this, just quick question for the chat. Has anybody never used Linux before? And it's okay if you haven't. I'm pretty sure it's not in 263. Do my Dora the Explorer stare at the camera. Good job. I guess question was pop that into the chat myself. That was a question. Have you ever used Linux? And if you haven't, that's okay too. Used or have not used? The question was originally have not used, but I figure we can either works. I have used. I have. Good. Linux is my jam. Ooh, even better. Sorry, went to go. That's fine. Okay. Okay, let me ask a quick question. Is it part of 263? So I should also mention, if you read my first email blast to you. This is my second semester at Grand Valley, so I haven't necessarily picked up what all the prereqs are. Okay, so I can't really expect you all to know that. 241, thank you. There it is. Basically, I will help you with the Linux commands. The only thing that you're going to use it for is moving stuff around on a web server. You do not need a web server to do WebGL. You can do it all on your own computer. But when you go to make it available to me for homework assignments, then you're going to have to do stuff. I agree. Definitely greatest thing. Okay, so we are going to be covering WebGL, and we are going to be covering all of the lovely things related to graphics programming, all of those lovely buzzwords. Integrating with VS Code, perfect. Um, hey, if you have any tips for VS Code, that'd be cool because I'm going to be using VS Code this semester myself. And I'm going to be using it straight up normal VS Code with the Vim plugin, of course. But we're going to be doing all the fun buzzwords that you may have heard of with graphics. So we're going to talk shaders, we'll type pipelines, texturing, rendering, all of those nifty things that maybe you've heard of with respect to graphics. We'll talk about them in here. Shaders are awesome. Get excited for them. Basically, you're going to be putting your graphics card to use. That's all a shader really is doing, is playing around on the graphics card. But we're going to be looking at mostly WebGL again. So I keep saying this term WebGL. If you have never heard of it, it is a variant of OpenGL. It's basically an extension of the embedded version of OpenGL that's been ported to browsers. And the neat thing about WebGL, well, there are two neat things really. One is it's extremely portable. RTX edition, exactly. RTX on, RTX off. Um, it's accessible to anybody using a modern browser, which is great. If you have ever written a video game or a graphical program or really any application and you've wanted to give it to somebody else, if you're making like a compiled binary, you have to compile it for their system, right? If you're all on Linux and you want to give me a program to run on my machine, I'm running Windows natively right now with the Windows subsystem for Linux, which is also awesome. You'd have to compile that for Windows for me, and then I would have to run the Windows version, right? Used to use Sublime. Yeah, I really like Visual Studio Code. It's been this past semester I really got into it. Um, but yeah, it's great. Actually, here, let me. So I've got my thing right here. Hey, here's my terminal, my Bash terminal. You can also run PowerShell in here too if that's your thing. But yeah, we'll get to VS Code here in a moment. But kind of the thing is that if you have a browser-based web application, anybody can run it, right? Just point me to your web server. You don't care if I'm on Mac or Windows or Linux or Raspberry Pi, it will run. Performance-wise might be different based on browser and architecture and whether you have a good graphics card or not, but it will run. You don't have to compile for different architectures. Now, the question you may have is, may or may not have, I'm going to assume you'll have this, is it slower, less performant? And then you get into some discussions there because yes, in theory, it's not natively compiled, but it's still pretty darn good. I mean, there are full-fledged browser games running WebGL, which are very impressive. And we'll kind of look at some of those later. So basically everything under the sun related to WebGL we'll be covering. Also Unity and Blender towards the end of the semester we'll look at. What we are not going to cover, I like to do this just to set the context for the class. We're not covering raw OpenGL. If that's something you want to learn, like C++ or Java OpenGL, you can take the concepts that you learn in here and apply it, but we're not going to be doing platform specific. We're going to be using WebGL. We're not going to do in-depth views on some of the tools out there. We're going to do kind of a high level, here is what this tool can offer you. And then if you want to learn more, do a deep dive on some of the available resources. We're mainly getting the graphics concepts. We are going to look at Blender and Unity, more so in how we can use them to get started and why using a tool like that is very, very attractive versus raw WebGL. But like things like, massive, sprawling, impressive projects in Unity, we're not going to necessarily cover. Unreal and Godot, we're probably not going to talk about. I've really grown to like Godot in the past semester, but I'm not good enough with it yet, and I think Unity is kind of a good starting point. If you are not aware, I don't know how many of you are game programmers out there. Unity and Godot and Unreal Engine, these are kind of the three big graphics frameworks that are out there. So Unity is a C sharp based thing. Unreal, I don't even know what language this one uses, but basically Unity and Unreal are kind of the two big ones for AAA style games. Unity's a little bit more approachable. Godot is what you do if you want to do Python. Yeah, Unity does have a really cool community on Reddit. Unity, at the end of, I think it was at the end of this past summer, they took all of their learning modules that they've got on their website. So it's like learn.unity.com, and they've made it all free. So before you had to subscribe and pay Unity monthly to get all their tutorials, and now they just made it open source, which is awesome if you want to get into Unity. Um, Blender is a 3D modeling tool that's open source, and if you want to do like 3D models, Blender is going to be your thing. But it's learn.unity.com if anybody's interested. You can basically, hey, let's make a 2D roguelike game. Here's a tutorial for how to do that. Um, if you want to do videos, animated storytelling, here's some tutorials for that. Unity's documentation is pretty cool. Godot's documentation is a bit on the iffy side, but there's some good YouTube videos out there for that. I've been liking Godot, but it's still iterating, I should say. Um, Other things too, so you will have a term project for this class. um, I'd ask you to maybe start thinking about what you want to do early on because I'll start asking you for term project ideas that you would want to work on. Since this is a graphics class, you may not kind of head towards the game design area. We're not really going to talk about game design too much. That's a class in and of itself, honestly, multiple classes. But we can talk about some of the basics of it. Like you need a forever loop to control a character, you need to update graphics, update enemy state, all that fun stuff. Um, but if you want to do a game for your term project, you are more than welcome to do that. You don't have to do a game. I've seen people in this class do like really cool music visualizers in the past. There was a student who did like a simulation of a heart because she was really interested in, I think it was biology was her secondary interest. But like, here's a heart beating, here's all the tendons connected to, or all the tissue connected to it, and how it all moves. And it's really cool. So games, simulations, visualizers, whatever you want to do. You do really cool stuff in graphics, basically. So just kind of things to think about. Now, I also like to ask this because I'm getting old and I'm starting to get out of gray hair, which means I'm getting out of touch. So if there is something that any of you want to cover in the class, please feel free to let me know. And if you have any thoughts, ideas, we'll see if we can work it in. This class will probably have some play with topics, but we're mainly be doing WebGL, Unity, and Blender is kind of going to be the takeaways there. We're going to start small in WebGL, work our way up to more complicated things, then we'll move on to some of the frameworks. But if there's something that any of you want to cover, more than happy to, at least try and talk about some of that. And with that, to help with this topic, here's your first Slido. So this is basically a way to give me live feedback on the screen. You can take a picture of the QR code with your phone or go to slido.com and put in this key code, and then you answer the question. It should pop up on the screen if you've never seen this before. And you don't have to have an answer for me now for this as well. If it's something you think about, hey, drop me an email or send me a message on Discord or whatever it is that you want to use to get a hold of me. But if there's anything you want to talk about, I'm more than happy. Did you enjoy working at Oakland? Yes, I did. I had a great time at Oakland. It was a very good university. I wanted to move over here to be closer to the lake. There, my past working life. This would have been year 6 for me at Oakland if I had stuck around there. Oakland is a very good school. I liked it. I actually did my master's there. Um, So it's a pretty good school. All right. Did you enjoy more modern stuff? Not. Oh. So that is fine. More modern stuff is going to be the frameworks. We'll talk about Unity and that at the end of the semester. The GL begin and GLN stuff is going to be a part of WebGL, unfortunately. So we'd be learning how to take models from Unity and Blender and upload them to the web. Yes, that is one thing we'll talk about. So when we get to, we will talk about models. It is a lot easier in Blender, or sorry, in Unity to handle that. It's possible in WebGL with some libraries like there's Babylon.js or 3.js, which can handle model loading. It's sometimes kind of wonky, so we'll have to play with it. Will we use shaders? Absolutely. I'm pretty sure that your second or third little demo is going to be shader based. So the thing about shaders is that everything is shader based. A shader is just a function, right? They have this kind of mythical, um, like people think they're this really cool thing. Shaders, come back, please. We'll use shaders. Um, all they are is a function that you send to your graphics card. You tell the program this is the data I want to send, and then the graphics card kind of chunks along. It's really good at things like multi-dimensional arrays, matrix math, things of that nature. But it's just a function. That's all it is. It's not like this mystical thing. This slide we're going to save for Thursday, because again, you'll get an email from me about the class. Basically, we're going to be doing a in-class lab. You'll get all of the fun info in an upcoming email. With that, though, I want to kind of point you towards the calendar because this is something I'm going to try to keep up to date for all of you. Let me go into preview mode for you so you can see what I can see, or I can see what you can see. There's this calendar thing here on the side. Click it. I'm going to try to keep class up to date with what we're doing when. So today's Twitch. The 21st is going to be a Zoom in-class lab. I'll send out an email for that after class. I just wanted to kind of introduce that here. But Thursday, I'll have you all introduce yourselves so I can know who you are. Alrighty. So, second slide. Have any of you ever set up your website on EOS before? So did you go through and set up your personal portfolio page? So it'd be something that looks like this, cis.gvsu.edu, tilde your last name. I'm kind of curious, what's? No. Okay. Nobody knows. Awesome. All right. So if I'm getting a lot of no's and what's, so to address the people who are saying what, you all have free web space on Grand Valley servers. So basically you can go to, I'm not going to set it up right now just because the VPN is going to kill my computer. But if you go to something like this, oh, it redirects to my actual page. But you have a place on the servers where you can set up a website. So like you don't have to pay for your own web host. And the only reason I ask this is because in class we are going to have personal websites. So you're going to put all of your homework assignments on there, your term project up on there. And I'm going to give you two options. You can either use EOS, which is going to be the school servers. You're also going to get Google Cloud Coupons, which is a cloud-based thing from Google where you can set up a virtual machine and basically host a website. And then it would live until the class is over, basically. Probably could do it on GitHub too if you want. I'm going to give you options, so as long as it's available on the internet, I'll be happy, more or less. But we'll talk about that a little bit later. Other things for the course. So we'll have in-class assignments. They'll be basically just Blackboard assignments that you fill out. Pretty easy. I don't really grade them too hard. It's more of a, were you in class and did you make an effort at answering the question? They're usually pretty straightforward. You're gonna have about 6 programming assignments. First one's going to be coming up pretty soon. 2 exams, term project. If you want to do teams, teams of about 1 to 3 usually work pretty well. If you want to go more than 3, we'll have to talk about it because I'll be expecting something a little bit more big, I suppose. So if you have friends that you've worked with before and you want to do like a team of 4 or 5, you're gonna have to get approval for that. Um, we'll talk about the term project pretty soon. Do I have any more on the term project? No. Term project, open-ended. If you have something you're passionate about, I'm expecting you to make that passion project. This is your chance to do something cool. So what we're going to talk about for the rest of today is the environment. Again, Google Cloud is something that we're going to use as a web host. You can also use EOS to host your website. Basically, the point is there's a lot to unpack on this slide here. You need a web space of some kind. Use EOS, use Google Cloud, use github.io, whatever you want to do, as long as I can access your assignments on the internet so I can help debug things, I'll be happy. Normally in the past, I've made people just use Google Cloud. Some people got it, some people didn't. I'll just make the offer available if anybody wants it, and I'll be sending out an email with the coupon link for that. Some links here at the bottom if you have no idea what I'm talking about with this EOS thing. Excuse me. If you're off campus, you need to be on the VPN for one. So here's how to connect to the VPN. The student web space is basically as easy as, where'd it go? There we go. Making a folder in your student directory. So make yourself a public_HTML folder, give it execute permissions, you have a website. It's that simple. It's very, very easy to get up and running. If you have any questions about how to do this, we can talk about it, probably on Thursday even. But links are in the slides if you need them. All right, pointer, come back. We'll talk about this more. Other things with WebGL, you can develop locally to your heart's content. Again, you do not need a server for this stuff until we get later when we have to start loading in things like modules and all that fun stuff. Then you need a server. But all you need is a browser and a text editor. Some of you in chat have mentioned VS Code or Sublime, or you can even use Notepad++ or whatever you want to use. All you have to do is create an HTML file and open it as a local file in your browser. But if you are doing it locally, I cannot help you troubleshoot. So keep that in mind. If you want to share something with me, put it up on your web server and then just send me a link to it. I can view the source of your code. Something I should mention too, actually, let's do this because I'll get 2 examples in one here and we can start moving along. I've got all the book examples from the Angel textbook. So basically I forked their GitHub repo and I updated all of them because they were slightly out of date. But if you want a link to do something, it's all up here. Like here is the Sierpinski gasket that you'll all be making. This is a fractal. Basically, it's just a bunch of points that makes up your Triforce here. We can do other stuff with it. So here's a little bit more of a triangular version instead of a point-based version. So let's pretend this is one of your assignments that you're struggling with. And you send me this link, assuming it's your web server. I can just look at the source code of the page. Okay, here's your code, right? So that's one of the other nice things about developing on the web. You can just pull up the script. Okay, so here's my main function for my vertex shader. Here's my fragment shader. Here's some of those nifty libraries I said we'll be using. Here's your source code. Okay, here's all my vertices. I've got a recursive function. Here's your problem exactly. I can look at it very easily. Otherwise, you have to like sling files over email to me and it gets a little bit messy. But we'll get to that. Point is, if it's available online, I can see it a little bit easier. And that makes your life a lot easier when it comes to getting help. Back to this page. So a lot of the early examples will be kind of based on some of these demos that are out there. Your first lab, I'm going to have you actually fork this repository because what it has inside of it is this common folder. You zoom in a little bit. This has the libraries that I'm talking about. So there are some basically matrix math libraries, MV and MV2. There's some shader initialization code in here. Basically, get your graphics card ready to receive information. Um, handle a lot of the headaches that you would normally have to do. These are all just nice little utilities now. So we're going to call an API and get our graphics card set up, get our canvas set up. You're only going to get these if you fork the repository or clone the repository, though. I'll show you how to do that later. Don't worry if this all sounds like horrible jargon for you. But here's the link to the repo if you want to start perusing it and see what's available out there. Um, somebody asked earlier about model loading. I think I've got a... I thought I had a model loader in here that I added. Yeah, Blender Mesh Loader. Please work. Oh, you're still not going to work, are you? Damn it. At one point, this was loading in a... must have been a mesh. Yeah, I I checked all of them except for this one. Damn it. Okay. A lot of this code was just boilerplate. I did not write all this, so don't get too freaked out looking at all this code here. At least I kept the link in there like a good little coder. I cited my source. Yeah, so there's your Blender monkey, which we'll all come to know and love. Basically, create a OBJ or STL file, and you should be able to pull it in with some of these libraries that are out there. Absolutely. Beautiful, beautiful monkey. We'll set it on fire later. That's always fun to do. Yeah, there's your mesh loaded into WebGL right there. Perfect. The issue more than likely is just a permissions issue, or it doesn't know where the object file is. It's not a bad thing here. Alrighty, let's go and do a little bit of code before we get done for the day. Okay, yeah, so one more thing. For your development environment, if you missed this earlier, use whatever you're comfortable with. I don't care how you create your websites. Use VS Code, use Sublime, Visual Studio, Eclipse, JetBrains, although JetBrains got some bad press recently. I used to just use Vim on my computer. Then I discovered VS Code is a beautiful VM or Vim plugin, so I'll be using VS Code. I'm going to be using Chrome because I can't get Firefox to be less annoying for me. I've also noticed sometimes Firefox tends to run WebGL a little bit slower. Not sure why, but Chrome seems to work a little bit better for me. For you, it might be different. Use whatever you want. Just make sure that your text editor is helpful. You know, if it does like syntax highlighting or things like that. Make sure your browser is current. Right? You can't use Internet Explorer 6 if that's what your work computer has. You need a current gen browser. So just keep it up to date. All right, enough talking. Let's do some code. So what is a WebGL program? For you all, it is a mixture of JavaScript and HTML. That's it. It's pretty easy. And what do we need from the HTML side? Honestly, all we really need is a canvas. So this is a newer HTML element. So it's the canvas tag. Basically, it creates a little playground for us. So we're going to create a basic website. So if you've never made a website before, again, I'm not expecting you to be web developers. Just copy and paste the code and change what you need to. What I'm going to be doing here is I'm going to copy and paste this into a new site. And then, let's do that, and then I'll talk about it as we go. I've got the demo, link to the demo here as well. But let's copy and paste this code. So the green is HTML, the blue is JavaScript. If you've never seen this before, let's get rid of my stuff here. And we're going to save this as an HTML file. So let's call this one hello there.html. Important thing if you're in the Windows world, if you're saving a file, save it as either all files or the extension it's supposed to have. Because otherwise it's going to make it into a text file, which is bad. We don't want a text file. All right, saved it as HTML. I get some pretty syntax highlighting here. Again, here's my canvas tag. This is where I'm going to render something to. And then JavaScript. We're going to change our formatting style slightly. This is more of a little demo here. I'm going to call a function main, and then I'm going to define the function, which is a little bit backwards, but it's just how kind of the demo goes. This function is going to do a couple things here. So first I need references to my various elements. So I'm going to get a hold of this canvas element. So here's my canvas ID equals C. And in JavaScript, I need this as an object that I can play with, basically. So the canvas is document.querySelector, and then #C. So this is basically going to be get the ID of the element. Again, feel free to use this verbatim. I could change this to my WebGL canvas. I can spell. And then I just have to change this here, WebGL canvas. All right, so these IDs just have to match, and the pound is important. If you like JavaScript, there are other ways to get elements, like there's document.getElement by ID, also valid as well, as long as we have the canvas as an object. Then we're going to take that canvas element and turn it into a WebGL drawing area. So this is going to initialize that canvas as something we can throw WebGL code at. All right, so we're going to say const gl equals canvas.getContext, WebGL. And then we have two actual WebGL commands here. So we're going to set the clear color, which is basically what is going to be sent to the canvas. You know, if this was OpenGL, it'd just be your screen. What color is the clear color? So when we say clear screen, it's going to draw that color. All right, so gl.clearColor, we're going to set it to that. We'll talk about that in a second. And then we're going to say gl.clearColorBufferBits, which references this prior line. Again, I'm not expecting you to know everything I'm talking about yet. I'm intentionally kind of going through this quickly. But what we have here is an RGBA value. Anybody know what RGBA means? Let me go ahead and save this while I wait to see if anybody knows. All right, this is demos. One, hello there. Red, green, blue, alpha, thank you. So these are going to be values between 0 and 255. Actually, no, sorry. Integer values 0 to 255. In floating point, it's between 0 and 1. Right, yeah, so we'll talk about color theory a little bit later on. Basically, how much red, how much green, how much blue, how transparent do you want it to be? So if I have this, so this is saying no red, no green, no blue, fully visible, right? So this is actually, oops, sorry, RGBA. So RGBA. Okay, so I saved that as one-hello there.html, and I'm just going to open this up in my browser. I get a black box. That's it. So I said no color. The absence of color is black. If I made them all one, so I want full red, full green, full blue, I'm going to save it, and I'm going to refresh. It's still there. It's just white. So if I inspect, so I'm going into the Chrome developer tools, different per browser. I hit Control-Shift-J to bring it up. You can also go to more tools, developer tools. You will become intimately familiar with this if you've never seen it before. I can pick this element here. No, it's still there, right? So it's not invisible. It's just white. And here I can actually see the code there as well. Let's make it red. What do I have to do to make it red? I have full red color, so 1.0. Change these to 0, so only red. Let's refresh. There's red. What about mixing red and blue? It's purple. So again, here's your colors. Here's your alpha. If I change this to 0.5, so I'm changing the alpha value, how transparent it is, it kind of becomes pinkish. Basically, if I had multiple layers stacked on here, I could see through things, right? It's opaque. So feel free to play around with this to your heart's content. You know, I can say, I'm a Spartan at heart. Let's make this green. There we go, green. So I also have the link to this demo up here. It's a little bit bigger. I think I just made it bigger for presentation purposes. But basic hello world of graphics, just draw a color, right? If you want to start looking at what's out there, I've got this WebGL samples, which is pretty cool. Here is an aquarium purely rendered in WebGL. So stuff like this just blows my mind that you can have in the browser. All right, so there's 500 fish there. Let's move it to 15,000. Still running pretty good. We dropped about 20 frames per second. But pretty good response for WebGL, right? And again, if I wanted, I could look at this code and see what they have going on. Um, yeah. So I've got some various links kind of sprinkled throughout this presentation. By all means, go check them out and see what's possible. WebGL is, to me, it's really interesting what you can do with it. Especially since this was so not possible, a handful of years ago. So the fact that this is all like cross-platform is great. So we've got this basic demo here. Other stuff we can do. So here is a little particle thing in a circle. So let's just draw some particles and update their positions. You can play around with this thing. Excuse me. This is just another like random, excuse me, like a random repository of WebGL fun stuff you can do. So here's a little particle generator type of deal. Other one. So this is the second one here is a term project for the author of the textbooks, one of his students a few years back. Basically, it's like I think it's a Voronoi diagram. Yeah, animated Voronoi. Basically, it's a procedural generation graphics kind of thing, but you can kind of see how all of these different objects are interacting with each other and kind of sliding off. It's kind of a cool little effect here. But point of this is that this Voronoi diagram, this is like a well-known algorithm in graphics and game design, and they just took it and they visualized it. And it's pretty cool. This is more exciting than the triangle. Yeah, a little bit more exciting. Not by much. But the cool thing about this, though, is if you go into the code and you look at it, um, so again, this person's using all these libraries that the book uses. Here's his vertex shader. Here's his fragment shader. Vertex and fragment we'll talk about very soon. Vertex is the position of things, fragments the color and texture of things. It's really not all that crazy what's going on here. And then he has his own script, which I should be able to open, I think. Yeah, and it's just some basic initialization code. So this project is not really all that much code, which is super neat to me. To me at least, I think this stuff's really cool. But yeah, feel free to check some of these out. And while you're doing it, look at the code behind it, because you can in all of these. They have to be rendered by the browser, so it's available to you, the client. So why is this cool? Again, this will work on any operating system with a modern browser. Linux, Mac, Windows, Raspberry Pi. Again, if you can get an Arduino with a modern browser on it, it would work on that. You also get this nifty thing too, where you can interact with it through HTML5. So this is one of the newer, at this point it's several years old, like ways of writing websites, that canvas element. You can have specific buttons. I mean, there's basically all kinds of new elements in HTML5. But if you are making a visualizer or a game in, say, OpenGL or SDL or any of the low-level graphics languages, you would have to code up what a button is. You'd have to code up what a text box is or a radio button, right? All of your standard web page elements are available to you to use. So if we go back, actually, sorry, let me go back to this guy here. This little panel, this is just a website form. It's like a little jQuery slider kind of thing, I think. But these are just text boxes, that you can change. This person didn't code this. They just wrote input equals pound FFFFFF. So you can basically get a lot of the headaches out of graphics programming um, in the browser, which is nifty too, I think. Also includes audio and video. So if you want to pipe music in or videos, there's the video and audio tags that exist now. You don't have to write that code, just use the browser for how it's intended. So basically you get all the benefits of modern browsers along with graphics. Okay, so before we, looks like we're actually almost done with class here, right? So let's talk about some practices. Let's make it look like an actual good deliverable. And that's probably going to be it for today. So we are going to be writing a lot of JavaScript and HTML code in this class. Make sure that your code is readable. Make sure it's well commented. Okay, I don't necessarily care about the GVSU Java guide, but make sure that like the top of your script file has your name and what this is supposed to be doing. What is this function doing? What is this crazy block of code supposed to be doing? Right? So by this point, I'm kind of expecting you to know how to program and hopefully how to comment code, but just make it readable so that I can understand what's going on. And maybe you don't care about how I feel about your code, but think of the version of you that's 6 hours in the future who has no idea what you did at 3 in the morning. Comment for your future self too, or your team if you're working on a team. But just make sure your name's on there and what the program's supposed to do and make it readable. Okay, so here is the same thing split up into two files. All right, so here I also have some nice little coding standards, which you could try out if you would like. But I've got the name of the file, I've got me, I've got what it's supposed to do, and then I've separated them out into an HTML file and a JavaScript file. Okay, so what this is going to do is the HTML file is going to set up all my website stuff. All right, so here's my HTML tag, my body tag, my canvas tag, and then import the script. It is important here to include the script after the canvas is defined, just how it is structured. Normally you'd do this all at the top and you would check to see, is this element loaded yet, to be a little bit more error safe, I suppose. We'll get to that. This is still the intro example. But then that's going to be all HTML. The JavaScript file is going to be all JavaScript. We're going to try to avoid mixing the two if we can. So we'll have a nice clean separation. And what you see in here is that you don't have like a script block in here. It's just raw JavaScript. So let me go ahead and do this now. So new file. Let's save this as 2 hello there.html. Okay, got that guy. Now let's copy and paste this code because typing is going to take forever. One thing I should mention too, this tripped me up when I was doing demos. If you are copy and pasting the raw code, make sure that things like quotes went through okay. That double lines with a bracket or right arrow didn't turn into like a real arrow. Let's see if I can get this to do it. Yeah, so like here, you see that little arrow that popped up? Website's not going to like it very much. This is an HTML comment. This is a JavaScript comment if you've never seen them. But let's get this into our hello world. So I called it to hello there. All right, so there's my HTML file. I need this blackbox.js file to exist. So I'm going to do a new file. I'm going to save it. I've got to go through the menu because I haven't figured out the keyboard shortcuts with the Vim module. It seems to kind of mess those up. So blackbox.js. This is a JavaScript file. We need this code. If you include this or this, it's also going to break. This isn't code. This is just for your information kind of thing. All right. So we have the exact same thing, except it is now nicely split up. So we still have our canvas element. We now have our script separated out. Here is our script. This is all just pure JavaScript. Now what we can do is we can go to this page. There's my black box again. Again, no change, just we've separated out our code a little bit better. And again, if I've messed something up, I can, if it's on a public website, I can send a link and say, hey, professor, check this out, it doesn't work. And I can say, oh, here's your problem. All right, let's say that I screw something up. I'm going to comment out this const GL line. I haven't tried this yet, so I don't know what's going to happen. All right, so it doesn't work. Well, crap. What are we going to do? Well, let's do a little bit of debugging. With most programs, if you run it on the terminal, you get an error message, right? Or you get a stack trace or a segmentation fault, whatever the problem is, you'll get the error in the terminal. In the browser, we have no terminal, right? We have no log that we can look at easily, but you can. If you go into the developer tools and you see the console here, what's the problem? Uncaught reference error, GL is not defined. Here is the exact location in your code where it's a problem. So this is kind of one of the other nice things about developing in the web is that you get the JavaScript console in your browser and you can go right to the issue. So I commented out const GL. GL doesn't exist because we never defined the variable. It tells me exactly where the problem is. So I said get used to using the developer tools. They will help you. If you get really deep into it, you can do things like set breakpoints, watch variables, all that fun stuff. If you're not a Chrome user, do I have Firefox in here? I do. It's been about a solid 6 months since I've launched it. Developer tools are in the menu, inspector, whatever I want to pop open, but basically similar idea. Here's your inspector, here's my console, all that fun stuff. I could just let's look at the same thing actually. GVSU. And if I'm going too fast or too slow, please let me know if anything here is not clear as well. I would encourage you to try this out though. All right, so here's my black box doesn't exist. Uncut reference error, GL is not defined. Here's the problem. Again, same thing. Takes you right to the issue. Just be aware of how to access the dev tools in your browser and you should be good. All right, so uncomment that, save it, refresh, bam. Life is good. All right, we've got 15 minutes left. Does everything make sense that I've shown you so far? Anybody lost? Makes sense. Cool. So good so far. Cool. Okay. Again, if you have web development experience, that will probably help you a lot. If you've never made a website before, just try out these basic demos here and see where you can go with it. You go over once more how to transition from having HTML to putting it on the browser. Absolutely. So, on my local file system, I have, all right, so demos. So I've got something like this, right? So I created 1 and 2, hello there. I've got my blackbox.javascript file. So these are just files on my computer. I could put them anywhere I want. It doesn't matter. Here you see documents. This is not a special place, right? So I could just double click it. There it is. I can also just open it in the browser. So there used to be like a file open menu years ago, but I just hit Control O and pick the file. Basically, you just need to open up a local file. Actually, that's a good question. Is that an option anywhere in here? You know, there used to be like a open local web page link somewhere, but it doesn't seem to be easy to find anymore. Unless if I'm silly and don't see it anywhere. Basically, Control O to open or Command O, or just double click it from your file explorer is all you need to do. So like here I've got 2. Hello there. So just double clicked it. But again, if you're developing locally on your computer, you can just use them as normal. What I can show you, let's do this for the, because I want to kind of talk about this whole website thing. What I'm showing you here is not in the slides. Well, it kind of is when I talked about Google Cloud. This is what you would see if you decide to go the Google Cloud route. Basically, I've created a virtual machine here, which is just acting as a silly little website. So like I can go to this link and I've got a basic web server. So you actually see this is a real live website. It doesn't have a domain name or anything cute like that because I'm not going to pay for a domain name. But if I can, yeah. So I'm going to upload my HTML file here. And this is kind of where I'm saying if you know Linux or if you're comfortable with Linux, this is helpful. I'll give you the commands if you do not know it. So I'm going to move hello there to www.html. Okay. A little bit off the rails, but don't worry. All I'm doing here is basically making this available online. So I can say one hello there.html. Hey, there's my square. But it's on a real live website that you can all access now, which makes it easy to see, again, for me to see what you're doing, for you to submit, also for you to make a portfolio if that's something that you want to show off to, potential employers. Hey, I did all this really cool graphic stuff. Just for fun, something I was playing around with. I was playing around with Godot a little bit over the break. One of the neat things about Godot and Unity and Unreal Engine is that you can export to various platforms, such as the web. So here's a little, like a roguelike style game. So this is WebGL under the scenes. I used Godot to make this. One of the browser or the development environments out there. If you touch the vampires, they quote Slayer's raining blood to you. But you can do lots of cool stuff in WebGL. That's kind of the takeaway. And this is a noise-generated environment. If anybody is into procedurally generated games, it's near and dear to my heart. These are all going to be different. Exactly. That's kind of the goal. This one doesn't have much. Oh, it's all the way down here. Dwarf Fortress is something I'm not super great at, but would love to be great at. Basically, the point is you're going to take your HTML and your JavaScript files and just put them on a web server, make them accessible to everybody. NetHack is fun, but man, it's got some annoying design choices to it. Okay, we've got 5 minutes, so that's probably as good of a point as any to cut off here. So we're going to start getting into graphics types things. Is there anything I want to show you? Yeah, that's probably good for today. Anybody have any questions from, anything we talked about today? Kind of the point was to do an intro to the class. Here's what we're going to be doing. Here's what you can look forward to. Hey, here's a fun little game that was made in WebGL. Anybody ever try this out? It's been a hot year since I've played this. But this is a WebGL game. I don't remember what any of the commands are. Oh god, it's gonna be bad. Oh, I was the sniper in here always. But yeah, WebGL. Look how quick this is running. And on the stream, it's not too bad either. Come on, I want to see at least another egg. Oh, what's the spatula? Oh, it's a spatula, or it's a... Capture the flag. Is it F? Are you on my team? I don't even know what team I'm on. Yeah, there we go. Woo! WebGL. Good stuff. Um, yeah. Uh, Quake Live. That's the browser based. No, is it Quake Live or Quake Champ? Whatever the browser based Quake was, that was WebGL. Um, Quake Live was super annoying for me because I was really big into Quake 3, and they botched the physics, at least from my perspective. Maybe I should give it another shot. This is all WebGL, except it's on Steam, so I don't know about that. But yeah, anyway, look for an email from me coming out soon. Basically, it'll give you instructions for the lab on Thursday. Sorry, um, Quake Live is WebGL. Original Quake is just OpenGL. Sorry, Quake 3 is OpenGL. Um, they had a version of Quake that you could play in the browser, and it was basically Quake 3 Arena ported to WebGL. Yeah. Alrighty. Any questions? Anything, any concerns, comments? But I think that's probably good for today. So what I will do is I'm going to take the recording, I'm going to pull it down, and I will get it up there on YouTube, and it'll be in the slide section. For FERPA concerns, you won't see any of your chats in there. But yeah, that's basically it for today. So otherwise, I hope you all have a wonderful day. Thanks for popping in for the first day of class. And I look forward to it's probably to be like half of a lecture and half of a in-class lab type of thing on Thursday. So probably one of the few times that we end a little bit early, but it was kind of a good natural time because then we're getting into a little bit of theory. So here's a nifty little guitar. Got some history for you. Let's look at cat eyes up close. And hey, bump mapping. I mean, graphics are cool in and of themselves, right? I mean, anybody could do graphics and it would be super fun. My other class is software engineering, and I feel bad for the students in there because it's very dry material. But anyway, I'll let you all go. Have a wonderful day. I will see you all Thursday, and bye for now. When will the triangle assignment be open for submission? Um, that's a good question. It'll be one of the things that we do in class on Thursday. So I'll probably make it available on Thursday-ish. It's just a get up and running kind of thing. Yeah, maybe I'll make it open sooner. We'll see. If you're already raring to go, I can make it open earlier. All right, so let me take a note of that. Kind of the whole point of the triangle is just to get you all up and running with the coding environment. So, alrighty, for real this time. Bye, everybody. Oh, we need some sweet outro music, right? Hmm. Sweet outro music. Aesthetic. There we go. Bye, everybody.